Okay, in this tutorial you're going to see how to program a PIC processor in assembler, and it's going to be the simplest program you can find. It's just going to use the PIC processor and a little LED with a resistor on it, maybe a 500 ohm resistor, and obviously just a power source, which would be in this case 4 AA batteries all connected together. I think I'm using rechargeables, so it works out to about 5 volts anyhow. And with this particular processor, it's an 8-pin, so it's nice and easy to work with. Doesn't take up a lot of space. And I'm using a PicStart Plus programmer, which is a fairly old programmer. It's so old that it never had a USB port. Matter of fact, it had a serial port on it, so I had to buy a special cable that did serial to USB to connect up. And just in case somebody else is in the same situation, I'll show you how to hook this up to Windows 7. You could do it to Windows XP as well. But in general, first of all, before you start doing this sort of thing, it's always a good idea to copy out the manual that you can get from Microchip on your processor. In this case, it's a PIC12F675. It's, there's my dog. It's about 139 pages. A lot of material to some, but some of the other books or the other chips will have up to 400 pages, and there's a lot of useful information. I usually create little tabs down here, and the pinout is really important, so stuff like this, and as well as acquiring information on registers. You know, you're always flipping pages looking for information about how things work. It has a whole bunch of different features inside these chips, including analog to digital conversion, has some EEPROM data as well, and types of oscillators. And one thing I think is kind of interesting is the instruction set, which basically is 35 instructions that you need to learn to program this chip, which makes it very easy to pick up and start away. They're all very common instructions that if you've ever done an assembler, you'll recognize a lot of the instructions. You know, things like adding a couple of registers together, or clearing a few registers, go-to statements, increment statements, return statements. You know, there's the not statement, you know, do nothing. But yeah, so there's a whole bunch of statements inside here. And as well, you can do other things with this manual, as far as finding out like the electrical characteristics and see if everything is designed the way you expect it to be. You know, things like I know that my 5 volts is good because this is saying that I can stay between 0 and 6.5 volts without blowing up the chip. Anyhow, let's have a look at this thing. You want to get the programmer. This particular programmer needs to be before you know how it works. Just let me plug in my camcorder. It's losing power right here. There we go. Okay, so anyhow, the programmer. I need to allow the MPLAB program that I'll be using wants to know which COM port that programmer is on. This is an old MPLAB, as well as the programmer being really old. They're both about 10 years old, but they still work on Windows 7. So what you want to do to find your COM port, if you have that situation as I do, is you head over to your Start button here, zip down to Control Panel. Inside the Control Panel, you'll see something called a Device Manager. You click on that. Inside the Device Manager, you'll see something called Ports, and you merely click on that and you find out what your port is that you're using, and it looks like mine is a COM3. The USB serial port is COM3, and that's really important information to bring back with you to the MPLAB IDE, and which we will go to now. Double click on it, open it up, and wait. Gee, takes a while for everything to work, eh? Okay, so inside the Programmer tab up here, you want to go down to settings, and in this case I want to find if my COM port is matched, and of course I've matched it to COM port 3. If yours was different, you'd obviously select your various radio buttons, or maybe even type in your COM port right there. Anyhow, it's all good here. So next thing you want to do, make sure your programmer is really connected properly to your computer. Select your programmer. Obviously mine was a PIC start, and enable it. What you should see is down in this window down here, some information pops up. This one merely tells me that I have outdated firmware. Oh gee, that's too bad. It works, so I'm not worried about it. So we move on. If you did not get some sort of indicator that you're doing fine there, you're obviously not connected with your programmer. Okay, so everything's good so far. What I want to do here is I want to start building my code right away. So in which case you go over here to File and you select New. And there you go, there's a window that has the code that you're going to type into it, right? So I put it up in the corner here maybe, about like that. And let me back away a little bit here. It's pretty hard working a camcorder and a mouse. But anyhow, okay, so one thing you should do here is create better tabs. Right click in this space here and go down and find properties. Properties, you want to select file type right there, and down at the bottom of file type there's a 4 in the tab size. Change that to a 10. That'll make it so that your tab sizes are much larger and it's easier to program in, so that when you start tabbing across you can have lots of space to work with. Now I don't actually want to type out all this code. I actually saved it ahead of time, and I'm just going to paste it in here. You obviously would have to type it out. That's all my code for this particular project. It's a little confusing here, so I'm going to remove some of the code just to make it so it looks like I can explain it a little bit easier. Okay, so really with this code here, first 2 lines. Okay, now this is assembler, as I mentioned. The first 2 lines are, well, in my opinion, mandatory. Actually, the first 1, 2, 3, 4, 5. Probably the first 7 lines in this section here I feel are mandatory, and I'll tell you why. And they're my own personal opinion, of course, but all my programs use these 7 lines always exactly the same. If I'm using, well, obviously the first line just tells you which processor you're really using, and in this case I'm using a 675, so a 12F675 gets typed in there, and this tells you obviously the origin of the code. It'll be starting at 00 hexadecimal, which I always use, and that's just the way it is. The next 5 lines are used because Microchip in their wisdom decided to deliver your all your chips stock, assuming that all the I/O ports, which there are 6 of them, would be used for comparators, which, yeah, some people might do that, but most of us hobbyists actually use all the ports for digital. So in which case these 5 lines, oh crazy screen, these 5 lines right here, they force the chip to run in a digital state instead of a comparator. And you might choose to use this for the first few times until you want to use the comparators, but anyhow, that's what that does right there. Let's close the gap here, just because I don't like extra space, you know what I mean? Okay, the next 2 lines right here, they define the I/O ports as what they are. So I'm just going to throw a remark over here. You can always use a semicolon to create remarks. What am I going to say here? Setup I/O as, oops, did I not give myself enough space there? Probably not. Okay, so a 3 and an E. I've chosen 3E very carefully, so a 3 is actually like that. 2 ones. And an E is like that. Okay, I guess you know I'm using binary right now. So this number 3E that I am using, which I will put into register 5, move literal into W, 3E. W is a working register, by the way. And I'm going to take that register, 3E in W. I'm going to put it into file register 5. What that does is it defines what my ports will be defined as. Obviously, I've got 6 to choose from, and the first 5, well, these 5 right here, will all be inputs. Just so I don't have any complications. And the first, obviously, IO port, or the first port, the 0 port, will be used as output, and the rest are all input. Whew, did I explain that? I probably not. Anyhow, let me quickly show you. Disconnect my camcorder. Where is the? This is why you should always copy out your book. You're always flipping around to it. Okay, so there's 6 I/O ports, right? You can see that the first 2 here, the pins that is, pin 1 and 8, they're both the power input for positive and negative. The rest of these, GP0, 1, 2, 3, 4, and 5, they're all your general purpose registers, or yeah. And right now, remember I put an output for GP0 and the rest are all input. That's the way it's set up, right? So go back and plug my little camcorder back in. Give me a second here. This is really low tech here, I guess you noticed that. So anyhow, so I've set up my ports as such. And let me just close the gap here. So all of the code up here are basically used to set the ports up, and that's it. Okay, so now I can really, at this point where I've typed in start, I can have my code that I want to do stuff with. For instance, if I type in bit set file register 050, register 5 actually at this point, by the way, you can see I was throwing the I/O information into port, or into register 5. This register 5 is actually different than this register 5 right here, because they are in different register banks, and the way you change between banks is you use this command here, the bit clear file register 035, or as you can see up here, bit set file register 035. They switch between the banks. So currently I'm in 0 bank, and in the 0 bank, register 5 is the register you placed your data on in order to have it output on your pins, right? So in this example here, that one statement right there, bit set file register 050, will put a high bit set on file register 5 pin or bit 0. So it's going to throw a high on bit 0. So if that program was to run, it would turn the light on if it was on pin, did I say 7? Yeah, on pin 7 or register 0, right? So in this program, sloppy typing, if I was to type out bit clear 05, 0, that would turn that LED off, or put a low on that port pin, right? On 0, GP0, which just, here we go again, GP0 right there, right? Pin 7, yeah, that one right there. plug my camcorder back in. Holy smokes, this is low tech. Where are we here? Okay, so if I ran that program, it would, in theory, turn the light on and off and then stop. And that would be it. And you'd say, great, program finished. But we can't actually see it, do it that fast. Every one of these steps takes 1 microsecond. And 1 microsecond is so fast that, well, 1/1,000,000th of a second, right? So I'm going to create some sort of a delay between the on and the off so that we can at least see what's happening here, right? So I'm going to call a delay, and I'm going to have to build the delay, obviously, when I get down to it. So I'm going to call a delay after I've turned it on. I'm going to call a delay also after I've turned the LED off, or thrown a low onto that port, right? So in doing that, I create a bit of a lag so we can see what's happening. Go to start. So you're getting most of the commands that you're going to ever learn right here. I mean, I think there's about, when I'm finished, there'll be at least half the commands, if not maybe a third of the commands that you'll need to know on this here quick little program. Go to start. I wonder how you spell start. Okay, so that little section there will be looping around in itself. So I better build my delay loop right here. And the good way to build delay is have a register count up aimlessly to some number and then slow the whole processor down, right? Just by doing aimless increments or decrements or whatever. And in which case I think I'll do a decrement. Decrement file register skip if 0. What that statement does is that will decrement file register 20 and skip the next line if it's 0. The 1 merely throws the result of the decrement back into, oops, what am I doing here? Back into register 20. So the next line, I'm going to call it go to delay. So what will happen here is when the program gets down to here, it will decrement register 20, throw it back into itself obviously, and it will check, and it'll skip this line. If it's 0, it'd go down to here. But in which case, it's an 8-bit register. It will take 256 decrements to ever get out of this hopeless loop here, and finally fall through to the next line. And since this is a very quick processor, well, it's relatively quick. Not in the world of processors, but I'm going to create another delay here. And this will hopefully slow it down enough that we can actually see what's happening, okay? So in this example here, you have a delay that will loop 256 times, and 1 microsecond per instruction roughly. Oh, that's 2 right there. So it's 3 microseconds times 256. Almost 1 millisecond delayed through there, and then it kicks through here and it does another 256 of this over and over. Anyhow, it'll work out to about 2/10 of a second, I believe. Something like that, I can't remember. Anyhow, it's enough delay that it will at least make it so we can see what's happening. And whenever you do a call, there's always a return required. So you want to return from where you came, so that's the command return is right there. So the way this little program works is turn the light on, bit set, file register 5, bit 0, call a delay, which is this thing right here, kill some time basically, run back up, turn the light off or the LED off, bit clear file register, right? And then call the delay again. And then finally, sorry about that, go to start. So it will continuously go around in circles here. Sorry, my camcorder holding skills are really bad. Anyhow, that's it. That's the program right there. What you want to do at this point, once you've got your program built, is save it as something special. You want to save it as something you can remember save it as, where's it save as section there? Save as, let's pick a name here. LED, that's a great name. LED, and what you want to do is over here, you want to select that you are going to use assembler code, right? That right there. So it will save it as assembler code. And save. Boom. So you know you've got assembler code there because it says it right on the screen there, led.asm. Okay, so now your code is assembler, and you want to go over to the project button, go down for a quick build. So you do a quick build, and over here in this output window it tells you that everything worked out fine, the build success. Okay, so now you've programmed, your first program is run through the compiler, and it's now ready to rock and roll. Let's pull this chip here and put it in my programmer the right way, like that. Okay, so next thing you want to do is you want to make sure that you've configured your programmer properly. So you'd select your device, and in which case mine is set for a 12F675. There are a lot of choices down here, and obviously this is the one that you have right there. If you had something else, you'd select that, right? Down here at the OK, you're good to go. One other thing with the configure tab is before you program, you want to configuration bits. You want to program these right here. That's really important. It's just as important as everything else. What you want to do is, if you want to have 6 I/O pins, one thing you should do is select internal RC with no clock. That way you save the 2 pins that would be used for everything else. Like a crystal or something like that on the external would take up 2 pins. This one does not do that. It allows you to have 6 I/O pins. Watchdog timer, I always turn it off. Power up timer, you can choose what you want to do. I keep mine on. Master clear, I keep it internal because external means it's going to use up one of your I/O pins or your input output pins. So with this setup here, I've got it so that my oh, and by the way, yeah, that I'll use 6 pins as input output, so you get your most bang for your buck out of your pin usage here. Also up in this corner here, or right here, if you find that this one's been ticked, deselect it so that you have control over these things. Okay, so anyhow, we've got that set up. Your configuration is good. Go over to your programmer tab here, and you will see that obviously you've selected your programmer. If you haven't, then you should. Mine's a PickStart Plus. There are many choices here. Next thing you want to do is enable it, and I think I did already, but anyhow, you would click on the enable key. What I want to do now is program it. So I select program, and you will see a couple things happen. First, down here you'll see that the light here, when I push a button, it will, give me a second here, flash. And obviously it's programming this chip. It took that program and put it inside this chip here. And also way down this output window, it told me the programming verification completed successfully. That's a good thing. That means everything ran. And we can pull the chip from here, bring it over to here. They should never do this with the power on. I'm just trying to speed things up. So, but anyhow, there you go. Which pin was it? It was, my output that I was doing was on pin 7, right? And I'm just going to plug my little LED in between pin 7 and ground. So there you go. Pretty simple.